In this lesson, we're going to learn about the Pythagorean Theorem. We can use the Pythagorean Theorem to find missing side lengths of a right triangle. The Pythagorean Theorem is a squared plus b squared is equal to c squared, where a and b are the legs and the c is called the hypotenuse. You can tell the difference between the legs and the hypotenuse. The hypotenuse will always be directly across from the right angle. And the legs, the A and the B, will be touching that right angle. A and B, it doesn't matter, they can be interchangeable. You can have A on the bottom and B on the side. Those do not matter. But what does matter is you need to have your hypotenuse is always the length that is across from the right angle. All right, so now we're going to use the Pythagorean theorem to find the missing hypotenuse. So we're looking for the C. And so I'm going to have this be my A, this be my B, and I'm going to also write for you the Pythagorean theorem formula. It's a squared plus b squared is equal to c squared. All right, so now we're going to plug in what we know and we'll solve for what we don't. So we're going to have then our A, the length is 28, so I'll have 28 squared. And my base is going to be b squared, which is 21 squared, and that's going to be equal to c squared. So 28 squared plus 21 squared is going to give us 1,225, and that's going to be equal to then our c squared. Now remember, we don't want c squared, we want c. And to undo c squared, or the opposite of squared, is to take the square root. So we're going to take the square root. And when I take the square root of c squared, I'm going to have c. And when I take the square root of 1,225, I'm going to have 35. So that length of our hypotenuse then is going to be 35. All right, let's try it again. So we're going to use the Pythagorean theorem to find our missing side, which is c, and that's our hypotenuse. So what we need to do then is I'll start again with my formula. A squared plus b squared is equal to c squared. And so then I'll have this be my A and my B, and it doesn't matter, you can have those interchangeable. What we can change around though is your C. All right, so I'm going to have 8 squared plus 15 squared, and that's equal to C squared. All right, so I'm going to take 8 squared plus 15 squared, and I will get then a total of 289, and that's equal to C squared. All right, so now again, I don't want c squared, I want just a c, so I'm going to take the square root of it. And so I'll take then on my calculator the square root of 289, and then our c is going to be equal to 17. So this side length right over here is going to be 17 feet. And again, notice you have 8 and 15, that's 17, that the hypotenuse is always your longest side. All right, so in this example, you're giving an A, a B, and a C, but we don't have it in the triangle. Either you could just plug this into the formula, or you could draw it out if it's easier for you. I'm just, again, going to write our formula. A squared plus B squared is equal to C squared. And again, we'll plug in the parts we know. And so I have 6 squared plus 8 squared is equal to C squared. And again, now you can use your calculators. So 6 squared plus 8 squared, and that's going to give me 100 is equal to C squared. So then again, we need to find the square root, and C then is going to be equal to, then 10 times 10 is 100. So we know that our C then is going to be 10. That hypotenuse, the side that's across from the right triangle, or right angle, is going to be 10. All right, let's do one more. Again, we'll plug it into the formula. All right, so we'll have 24 squared plus 45 squared is equal to C squared. All right, so again, use your calculators. And I'll get 2,601 is going to be equal to C squared. And now we're going to take the square root of it. So we'll take the square root of that, and I'll have 51 is going to be equal to C. All right, so use the Pythagorean theorem to find the missing leg. All right, I'm just going to draw this, redraw it. I'm going to kind of turn it so that you can better see this. The B is on the bottom there. Here's our right angle. We have 36, and then 39. All right, so now we are looking for the B. So let's again, I'm going to start with the Pythagorean Theorem. A squared plus B squared is equal to C squared. And so I could assign this the A, we have the B, and this is our C over here. So what we're going to do then is we're going to plug in what we know and we're going to solve for what we don't. So we'll have 36 squared plus B squared is equal to then 39 squared. All right, so now let's do a little bit of simplifying. I'm going to take my 36 squared and I'll get 1,296 plus B squared is equal to then 39 squared is equal to 1,521. All right, so now we're going to continue solving and we want the B all by itself. So I'm going to just minus the 1,296. All right, so my B squared is equal to 225. All right, and again, I don't want to have a B squared, I want just a B. So just like we did before, we're going to take the square root. And so I'll have a B is equal to then, I'll take the square root of 225, and you're going to have 15. And so we know that our B then is going to be 15 inches. And again, take a note that we have a side that's 36, and then 15, and then our biggest side again is that still going to be that hypotenuse. All right, so let's go ahead and we're going to do it again. We're finding the missing side. Again, I'm going to put my A squared plus B squared is equal to C squared. All right, so now I know my A, my B is going to be on the bottom here. Again, the legs are the ones that form that right angle, so they're the ones that that touch it. And then my C is going to be 50. So again, I'm going to take my A squared, I don't know that, but I do know my B squared, which is 14. I'm going to square that, and then I'm going to square my C, which is 50. All right, so let's do some simplifying. A squared is equal to 190, plus 196 is equal to then 2,500. And then let's just continue solving, minus the 196. And I'm going to get A squared is equal to 2304. All right, so again, we do not want to have the squared, so I'm going to have the square root then of 2304, and I'll have a side length then of 48. So that means that this right here, that side is 48. So 48 millimeters would be the answer to that one. All right, so here we have the next one. Now this one, again, you could draw it out if you wanted to. I have the A is missing, so I'll plug it into my formula. And so I'm going to have my A squared plus my B is 24, and that will be then equal to 30 squared. So again, I'm going to just simplify, and you have 576 is equal to then 30 squared is equal to 900. And again, we're just going to continue trying to get that A by itself. So A squared is equal to we have 324. All right, again, we don't want the A squared, we just want to have A, so we're going to take the square root of it. So take the square root of 324, and A is going to be 18. All right. All right, one last one. We're missing the B, so we're going to plug it in again. 16 squared plus B squared is equal to then 34 squared. All right. So 256 plus B squared is equal to 34 squared. You have 1,156. And again, we just need to isolate that variable. 900. So then we're going to take the square root of that as well because we don't want b squared, we want b. b is going to be equal to then 30. All right, so the b is 30. Example 3, see if a triangle has a right triangle. Determine if the given side lengths make a right triangle. This is also called the Pythagorean triple. Something that we need to keep in mind when you're looking at if it's a right triangle, that we have this right triangle, and here these are our legs, our A and our B and our C. Our C is at hypotenuse, and it is always the longest side. So let's assign this triangle our side lengths. I would have 80, I would have 192, and then this we could have is 208. You need to make sure that that hypotenuse, it always is our longest length. Now, in order to form a right triangle, that means that you can put it into the Pythagorean theorem, and it is going to actually be equal, because a squared plus b squared of a right triangle is going to equal to c squared. So let's go ahead and let's plug this into this formula, and then we're going to see if it works. So we'd have 80 squared plus 192 squared, and is that equal to 208 squared? So 80 squared plus 192 squared is equal to 43,264. And 208 squared is also equal to 43,264. So because these are equal, is this a right triangle or does it form a Pythagorean triple? The answer to that is yes. All right, let's take a look at the next example. I have 52, 48, and 15. And again, remember on the right triangle, if it is a right triangle, our A and our B and our C, and that C has to be the longest side. Now notice these numbers are not in order from the two first ones being the legs and then the last one. So you need to place the biggest number, the biggest side has to be that C. And then it doesn't matter about the 48 and the 15. Let's just make this our 48 and then this side being our 15. So let's plug it into the Pythagorean theorem. Again, we're going to have a squared plus b squared is equal to c squared. And so we'll take 48 squared plus 15 squared, and is that equal to 52 squared? All right, so 48 squared plus 15 squared is going to give us 2,529. And now is that equal to 52 squared? And that's going to give us 2,704. Because these are not equal, then no, this does not form a right triangle or the Pythagorean triple. All right, let's check the next two then here. I'm going to take, then again, I'm making sure that that's my biggest side. I don't know if they're always going to be put in order for you. If they're not, you need to make sure that the C is your biggest side. 19 squared plus 22 squared, is that equal to 26 squared? So, and if they're equal, they form a right angle, or right triangle. If they don't, then we know that they're not a right triangle. So 19 squared plus 22 squared are equal to 845. And then let's check our 26 squared, and that's equal to 676. So no, they are not equal. So no, they do not. All right, so let's take a look at this last example. Notice how we have 35, 37, and 12. Again, remember that c squared has to be the biggest side, so we're going to save that to be on the end with the c squared. So I'm going to assign 35 as my a squared, and then my 12 for my b squared, and because 37 is our longest side, that is going to be then our hypotenuse. So 35 squared plus 12 squared gives us 1,369, and is that equal to then 37 squared, which is equal to 1,369. And because they're equal, we will then say yes, this does form a right triangle or the Pythagorean triple. In this lesson, we took a look at using the Pythagorean theorem to find missing side lengths and to determine whether or not a triangle is a right triangle.